Today we are going to talk about the image recognition, and in our project we mainly focus on fingerprint matching. Fingerprints are the ridges and valleys on each tip of our fingers, and they form from pressure from the baby's developing fingers when they are in the womb. So fingerprints are a unique marker for everyone, even an identical twin. Fingerprint identification are widely used in both crime investigation and security. This is mainly because of these four reasons. First one is the uniqueness. There is 1 in 64 billion chance that your fingerprint will match up exactly with someone else. And secondly, it is immutable. That means even when people getting older and older, the fingerprint will not change. And the third reason is because of it is inexpensive. So it is widely used. And the last reason is because of even when a finger get injured, it can be recovered. So now Jason will talk about how the fingerprint matching works.
For fingerprint matching, first we need to scan our fingers to get a sampling, and then we'll have some image processing and extracting some features and characteristics in our fingerprints for further comparisons and matchings in the final step. And we are now talk about the image processing and extracting the characteristics, and then followed by the matchings and verifications, and finally Toby will be talking about some scanner in fingerprint. In fingerprint matchings, after we obtain the image from the sensors, we have the image processing, and it is also called the pre-processing. And the ultimate goal is this: is to have a 1 pixel width ridge line. And there are mainly 4 steps here: is the histographical equalizations, and low pass filtering, and binarizations and thinning. And for the histogram equalizations, it is used to increase the contrast of the image, and then we will follow it by the low pass filtering, which is equal to what we discussed in the lectures, is to remove the noise in the image to smooth the image. And then we will follow by the binarizations to convert the image to a grayscale and bit art image. And then we will thinning the image to reduce the complexity, and it is more easier for the foreign process. And here is the figures that during this process, and you can see that the binarization is totally become in grayscales, and after thinning, and those red spots is the characteristic of the fingerprints, and which is the post-processing in this area. And in the post-processing is extracting the phenotype of our fingerprints, and we are mainly have 2 characteristics. First is the endpoint, and the other one is the bench point. And we define the endpoint as the pixel only has 1 neighborhood, so it will be the endpoint. And if the pixel has 3 neighborhoods, then it will be the bench point. And here is the ending, and here is the bench. After we identified the characteristics, we will compare the image from database to verify whether the fingerprint is from the same finger. However, in our practical processing, we cannot compare all visual information from the image because the data will be too much for that. So we will just compare the relative positions of our phenotype data and characteristics of the fingerprint. And all those characteristics will be stored in the database before verifications. And now Toby will talk about the scanner.
there are two types of fingerprint scanner, which are capacitive scanner and the optical scanner. Firstly, I will talk about the capacitive scanner. It is mainly using the electrical current to figure out the fingerprint. As you can see here, there are two condenser plates, and the finger acts as the third capacitor plate. When the distance between the fingers and the capacitor plate becomes closer, the capacitance of this capacitor will be higher. So the valleys and the ridges on the fingers produce different voltage outputs. So we can discriminate between finger reach and finger value. And secondly, I would like to talk about optical scanners. It is based on the light which illuminate from this illumination source, which is CCD. And it depends on the brightness of the reflected light, and the optical scanners can depict the ridges as dark image and the valleys as light image. And last but not least, these are the examples of fingerprint matching. And here's our presentation. Thank you.
Thank you very much. Questions?